Good day, everyone. Welcome to our Earth and Life Science virtual classroom. I am Ma'am Chelanti de la Cruz of Malinta National High School. Join me in this another amazing and fun-filled discussion as we continue to unravel the beauty and wonders of life and planet Earth. The topic that we are going to discuss today is all about comparing and contrasting the formation of the different types of igneous rocks. This was taken from the list of most essential learning competencies given by the Department of Education. Specifically, at the end of today's session, you should be able to describe how igneous rocks are classified, differentiate the formation of intrusive and extrusive igneous rocks, and cite some common uses of igneous rocks. So prepare your pen, paper, and self-learning modules, for we are about to begin with our discussion. For today's topic, you'll be needing the knowledge you learned from last live stream session in Earth and Life Science about the three types of rocks, which are igneous, sedimentary, and metamorphic rocks. Let's begin with our first activity. In this activity, I want each of you to act as a rock detective assigned to sort a collection of rocks found near a volcano into two groups. How will you do it? I'll be giving you 10 seconds to type in your answers in the comment box. Okay, time is up. Let's check if you are correct. If you classified granite, gabbro, pegmatite, and diorite as one group, and obsidian, basalt, andesite, and pumice as another group, then you did a great job because that is the correct answer. Now let's go back to the rock collection I presented earlier. What is common among the rocks in this collection? Very good. These rocks are all examples of igneous rocks. Igneous rock or magmatic rock is one of the three main rock types. The others, like what I mentioned earlier, are sedimentary and metamorphic. Its name was derived from the Latin word ignis, which means fire. So where do these rocks come from? Exactly. These rocks form when magma cools and crystallizes either at volcanoes on the surface of the earth or while the melted rock is still inside the crust. Now that you know that the rocks from our collection are all examples of igneous rocks, my next question now is, what made you group the rocks this way? What served as your basis? Very good. You may have observed that the grain size of the rocks in column A is different from the grain size of the rocks in column B. This way of grouping igneous rocks into two is known as the classification of igneous rocks according to grain size. Using this criterion, igneous rocks can either be intrusive or extrusive. Let us now compare the formations of these types of igneous rocks and discover how location, material origin, and cooling rate affects the texture and grain size of a rock. Let's begin with intrusive igneous rocks. Intrusive rocks are also known as plutonic rock. It is from the word plutons, which mean large bodies of magma that solidify even before reaching the surface of the crust. This type is formed inside the Earth's surface using the molten materials found underneath called magma. Since the temperature at this location is hotter than above the Earth's surface, cooling happens slowly. This gradual rate of solidification allows time for large crystals visible enough to our naked eye to form, thereby giving intrusive igneous rock a coarse-grained texture, scientifically called paneritic texture. Examples of rocks under this classification are granite, gabbro, pegmatite, and diorite. Extrusive rocks, on the other hand, are also known as volcanic rock. It is formed when hot magma from inside the earth flows out onto the surface as lava. Since the temperature at this location is cooler, cooling happens quickly. This rapid rate of solidification produces volcanic rocks with small crystals which cannot be seen by the eye or with a hand lens. The presence of these small crystals give extrusive igneous rocks a fine-grained texture, scientifically called apanitic texture. Examples of rocks under this classification are obsidian, basalt, andesite, and pumice. Let's now proceed with our second activity. This activity is entitled Sorting Hat. In this task, I want each of you to act as the sorting hat in the Harry Potter series and the rock collection as the wizards studying in Hogwarts. If the task of the sorting hat in that movie is to classify students into 4 houses, your task in this activity is to sort the following rocks to form 4 groups. How will you do it? I'll be giving you 10 seconds to type in your answers in the comment box. Okay, time is up. Let us check if you are correct. If you classified granite and rhyolite, diorite and andesite, gabbro and basalt, and peridotite and comatites together, then you did an excellent job because that is the correct classification. If you notice, rocks under similar group are almost the same in terms of color. This is because these rocks have the same mineral composition and proportion, which is another way of grouping igneous rocks. Using this criterion, rocks can be felsic, intermediate, mafic, or ultramafic. Felsic rocks like granite and rhyolite are typically light in terms of color because they are rich in feldspar and iron. Intermediate rocks like diorite and andesite has equal amount of dark and light-colored minerals. Mafic rocks like basalt and gabbro are typically dark in terms of color because they are high in magnesium and ferric oxides, while ultramafic rocks like peridotite and comatites are rocks that are rich in magnesium and iron but low in silica. Now I have a question. Can rocks coming from identical magma with same mineral composition and proportion becomes 2 different rocks? Very good. The answer is yes. Rocks coming from identical magma can become 2 different rocks depending on whether they cool quickly or slowly. One can become an intrusive rock and the other can become extrusive rock. For example, gabbro and basalt are both mafic rocks, but gabbro is intrusive while basalt is extrusive. This applies too with diorite and andesite, granite and rhyolite, and peridotite and comatites. Igneous rocks, regardless of their classifications, have a wide variety of uses. Let's discover these uses through our third activity. In this activity, I want you to match the rock sample in column A with the material they produce in column B. You have again 10 seconds to answer this. Time's up. Let's check your work. Granite is commonly used in kitchen countertops and tombstones. Obsidian is used in making sharp tools and jewelries. Pumice can be used to remove dead skin cells and calluses, while basalt is used as aggregates in construction projects. Before we proceed with your assessment, let's have first a brief recall of what we have discussed. Igneous rocks are formed when hot molten rock crystallizes and solidifies. Scientists use the term magma for molten rock that is underground and lava for molten rock that breaks through the Earth's surface. Igneous rocks can be classified into 2 if based on their grain size, and into 4 if based on their mineral proportion. Intrusive igneous rocks are formed from magma that cools and solidifies within the crust of the planet. This type of rock cools gradually without ever reaching the surface. They have large crystals that are usually visible even without a microscope. Extrusive igneous rocks, on the other hand, are formed on the surface of the earth. They are formed from lava. Since this type of igneous rocks cools rapidly, crystals formed are small. In terms of mineral proportions, igneous rocks can be felsic if rich in feldspar and silica, intermediate if it contains lower proportions of silica than rocks in the felsic family, mafic if rich in magnesium and iron, or ultramafic if the rock has a very low silica content but rich in minerals such as hypersthene, augite, and olivine. Rocks from identical magma can look different depending on whether they cool quickly or slowly. Igneous rocks have a wide variety of uses. Let us now test your knowledge. I want you to analyze each statement as I read them, choose the letter of the correct answer, and write it on a piece of paper. You'll be given 5 seconds to answer each question. Let's begin with question number 1. Which is not a characteristic of granite, a common intrusive igneous rock? A. It is generally light in terms of color. B. It has a glassy appearance. C. It has a paneritic texture. D. It is mostly made up of feldspar and silica. You have 5 seconds. The correct answer is letter B, because granite has no glassy appearance. Question number 2. Why are the crystals of an intrusive igneous rock typically larger than those of an extrusive igneous rock? A. Because the magma cools very quickly. B. Because of a higher water content in the magma. C. Because the temperature of the magma is much lower. D. Because the magma cools much slower. The correct answer is letter D. The crystals are larger because the magma cools much slower. Question number 3. What type of texture results when an extrusive igneous rock cools so quickly that crystallization does not occur? A. Porphyritic. B. Glassy. C. Paneritic. D. Apanitic. The correct answer is letter D. The fine-grained texture of extrusive igneous rock is also called apanitic texture. Question number 4. Which is not a common extrusive igneous rock? A. Basalt. B. Rhyolite. C. Andesite. D. Granite. The correct answer is letter D, because granite is an example of intrusive igneous rock. Question number 5. What are the 2 ways the igneous rocks can be classified? A. By luster and color. B. By radioactivity and polarity. C. By mineral proportion and grain size. D. By mass and volume. The correct answer is letter C. Igneous rocks can be classified according to their mineral proportion and grain size. Kindly type in your scores in the comment box so I can see how well you understood the topic. Very good! Most of you got a passing score. If you still have some questions or point of clarifications about our topic today, you may ask your respective subject teacher about it on your next follow-up discussion. I hope you learned a lot today. Thank you for watching and listening. See you again on our next live stream session, and together, let us continue to discover the marvels of life and planet Earth.